Hello everyone. So after quite some demands here on LinkedIn, I would like to show to you how to create an Aras Innovator PLM agent that is connected to Anthropic's Claude using the Anthropic MCP protocol. So first of all, what can we achieve with this? Well, we can have an agent, an LLM, that can do actions for you inside a PLM system. So it's able to retrieve data, organize data, also add new data. And that's what I'm going to show you right now. So as you can see here, I'm in my Aras Innovator PLM instance, and we are looking at part grid. So there are some MP parts and some other test parts, but this is a testing database. So there's no sensitive data. And I will now ask the agent to give me a list of all part numbers. So I will give the model some context that it can connect to Aras Innovator and then ask for the part numbers of the part item type. Right now it's connecting and it's trying a first operation. As you can see, it fails sometimes, but it doesn't matter because it will try to correct itself. And there we go. Now we have all the part numbers and a nice bullet points output. Okay, so now on to the next topic. Let's add a list of users with Dutch names. As you can see, it made another mistake, but it's no problem because it will correct itself until it works. And as you can see, it succeeded. So there we go. 6 users have been added. The users are Jan van der Berg, Maria de Jong, Pieter Bakker, Anna van Houten, Thomas Visser, and Sophie Mulder. So right now, we are going to check inside the Aras Innovator database. I go to the users item type, search a grid, and there we go. We have Anna van Houten, we have Jan van der Berg, Maria de Jong. So this is just a very short and brief example of how you can automate tasks that would usually take you much more time. Now, lastly, the third demo, I will create a parser. So I'll create an assembly with maybe 5 parts underneath. So I'll ask Claude again. So I'll ask it to create a simple assembly of a product, including the descriptions, and it should have 5 components inside of it. In the meantime, I'm going to show you parts table. So these are the current parts. We have 9 results in there. And we go back to the agents. Okay, there we go. It added another bicycle assembly with 5 components and structure comp with a number inside of it. So let's see if that worked. All right, we see an assembly and we see some components here. So that worked. Now we will open up this assembly. All right, so it's created this assembly item and it has description in there, but I see it failed to add the parts in the bottom. So of course, what you could do if you develop a model like this, you could prompt it and do some prompt engineering so that these kind of things will always go right the first time. But right now I will just ask the assistant and say, good work, you forgot to add the components inside assembly. As you'll see, it acknowledges the issue and it tries to now add all these components inside. And as you can see, I do not have to specify any API logic. That's the whole point of having an MCP server. It will just iteratively explore the data model and then try to build up the structure. And there we go. So now it says it succeeded. So I will go back here, open assembly again. And there we go. All the components are inside assembly. Okay, so now you can imagine, in this case, we are only using one MCP to connect it to one database. But in real world practice, we would use maybe an ERP system, a tool management system, connect everything to this agent so it can do multiple tasks. And that's really where you start seeing this digital thread, or actually an autonomous digital thread, starting to evolve. So this is very exciting for the industry. Thank you for watching.